Hi, I'm Rob Buells, lead developer of the JBrowse genome browser. This short video gives an overview of the primary features of JBrowse. Like most genome browsers, JBrowse lets you scroll back and forth through a genome, displaying data in multiple tracks on the screen. For this demo, we're using a set of artificial test data. Let's turn on a few tracks. We can either drag them from the track list on the left into the main display pane, or we can double-click them. To scroll back and forth, we just click and drag in the main pane. If we double-click in the main pane, we zoom in, and if we shift double-click, we zoom out. We can also do these things using the buttons in the navigation area at the top. Another way of navigating in JBrowse is what's called rubber band zooming, or dynamic zooming, where you can highlight parts of the display that you want to zoom to. You can do this either in the overview or in the main pane by shifting and dragging. To find a specific feature or reference sequence by name, just type its name in the location box at the top. Let's type the name of a test feature, F14. Notice that as I type, JBrowse suggests names of features that match what I've typed. So far, I've only typed F1, but JBrowse is already suggesting F14 as an option, so I'll click it to select it, and then hit Go to jump to it. Notice that Example Features, the track that contains F14, is automatically brought up to show the feature we're searching for. JBrowse is capable of displaying a wide variety of data types, and has support for many popular file formats, including GFF3, BED, BAM, Wiggle, and Bigwig. One of the best features of JBrowse is its ability to display data directly from BAM and Bigwig files, with no pre-processing necessary. This means that if your Bigwig or BAM file is accessible on your web server, you can just add a track entry for it in the JBrowse configuration, and it'll be ready to go. First, let's have a look at some alignments from a BAM file in the track labeled volvoxsorted.bam. We'll turn off these tracks to give us some space, and then we'll drag volvoxsorted.bam from the sidebar into the main display pane to turn it on. This is a simulated genomic resequencing dataset with next-gen reads of 100 base pairs, shown with a JBrowse alignments track, which is optimized specifically for showing next-generation alignments. As we scroll through, we can see that this data includes both sequencing errors and some SNPs. It's easy to see visually where the reads agree on a sequence that is different from the reference, since it looks like a column of a different color. To see all of the detailed information about a particular read, just click on it, and a window showing all of the data for that read will come up. Once again, all of this is being displayed directly from the BAM file itself. As we scroll around, JBrowse is fetching small pieces of the file as needed, which works with even the largest BAM files. Similarly, JBrowse can also display quantitative data directly from Bigwig files. Let's turn off that alignment track and turn on a couple of tracks that demonstrate the Bigwig functionality. These are two different views of data from the same Bigwig file, which contains some made-up quantitative test data. The upper track, labeled Bigwig Density, is a JBrowse Wiggle Density track, set up to show the quantitative data as colored regions, blue for values above the dataset's global mean, and red for values below the dataset's global mean. More intense blues and reds indicate values that are further above or below the mean. The lower track, labeled Bigwig XY, is a JBrowse Wiggle XY plot track, which shows a bar graph of the quantitative data. This one is configured to show the values as blue bars of varying heights, along with a yellow line showing the data's global mean, and gray shaded regions showing 1 and 2 variances. And, just as with the BAM track shown earlier, JBrowse fetches small parts of the bigwig file on an as-needed basis, so this works with even very large bigwig files. What's more, beginning in JBrowse 1.7, all of this data can be exported to a variety of file formats. For example, to get the quantitative data for this particular region in a bedgraph file, I can just go to the menu for this track, hit Save Track Data, choose to save the visible region in bedgraph format, and click View to see the bedgraph dump of the data in the currently visible region. And there we have our bedgraph file with the data from this region. If we want to save it to disk, we could just hit the Save button here, or we could also have hit the Save button on the previous screen. This data saving functionality works with all of the major data types supported by JBrowse, and can save files in FASTA, GFF3, BED, bedgraph, and Wiggle format. Next, we'll navigate to a different set of test data for 1800 tracks from the Modern Code project, looking at another exciting feature of JBrowse, the optional faceted track selector. This track selector would probably only be used by an installation that has hundreds or even thousands of tracks. So with the faceted track selector, you can progressively narrow the set of tracks you're interested in by selecting the attributes you want them to have. That is, by searching one or more facets of the track data. So in the track selector, click to select an attribute, and then click to select the values that you want that attribute to have. Say we want to find tracks with data from the Waterston lab. We go over to the Principal Investigator facet, right here, and in there we see a list of PIs whose labs are generating these Modern Code tracks, with a count of how many tracks come from that lab. So we select Robert Waterston, and the display updates to show that there are 230 tracks for Robert Waterston. So now, let's say that we only want RNA-seq tracks. So we go to Technique and select RNA-seq. And then if we go back and look again at the Principal Investigators section, you see that the PIs and counts have changed. The list of values for each facet is affected by what is selected for the other facets. So now that we have selected RNA-seq, the Principal Investigators facet only shows PIs that have RNA-seq tracks, and it shows a count of how many RNA-seq tracks they have. So, now we have 89 matching tracks. Finally, let's say that we're only interested in tracks that involve C. elegans dower larvae, so we type dower in the text field. This narrows it down to 3 tracks that satisfy the criteria. They're from Robert Waterston's lab, they're produced with RNA-seq, and they have the keyword dower in their metadata. Now let's say we change our mind and we don't want to limit it to just RNA-seq tracks. We can either click RNA-seq under Techniques again to clear that selection, or we can just hit the red X next to Technique to clear all the selections we have for Techniques. Click that and we're back to 17 matching tracks. That's 3 RNA-seq tracks and 14 integrated gene model tracks that match. So if we want to start turning these on in the display, we either check the box next to each of them, like this. You can see over here on the right that the tracks are turning on. Or we can turn all of them on and off together by clicking the box in the column header. And finally, if we want to clear our selections and start again, we can hit the Clear All Filters button, and then we can go ahead and find more tracks if we want. One last thing to point out. The Faceted Track Selector also has a couple of special categories for tracks that are currently turned on, currently active, and for tracks that have been recently used. You can use these as search terms like anything else. So if we want our recently used tracks for dower larvae, we can just select recently used and type dower in the search box, and there we have the 10 tracks that we've recently used that include the term dower. This concludes the overview of JBrowse's main features. Visit jbrowse.org for more screencasts, as well as live demos and links to documentation about how to set up your own JBrowse genome browser. Happy browsing!